Okay, so here is our video for 2.7. So let's jump into it. So what we've done so far is we've talked about functions in general and linear functions, and then last time we combined functions by shifting them, moving them around, stretching them. Well, now we're going to take two functions, maybe f of x and g of x. We're going to add them, subtract them, do a bunch of other stuff. So if I take f of x plus g of x, and I add them together, I get a new function. And what we're going to call it is, we're going to call it f plus g of x. That's its name. So we can write it f plus g of x. That just simply means you take f and you take g, you plug in x into both, and then there you go, add them together. So for this one, if you can imagine, if we plug in a value for x, it has to make sense and give you an output here, or in other words, it has to be in the domain of this function f. And then if I plug in a value here, it has to be in the domain, or make sense, be in the function g. So if you want to get something out of f plus g, the input has to work in here, and it has to work in here. That means if a is the domain of f, then anything in here has to be in a, it has to work for f, and it has to be in b, its domain. It has to work for g. So if we want something that's both in a and b, then we use a little intersection sign, and that just means that the domain of my function f of x plus g of x is just the domain of a plus intersect with the domain of b. Okay, so, and we'll look at what that means in a second. So if I've got f of x and g of x, and I want to make a new function, I could subtract them. I would call it f minus g of x. Well, again, if you're going to plug in an input, if the domain of f is a, then it's got to work. If I want to find out what f minus g is, any input has to be inside of a, that domain, so it works. It also has to be inside of b, which is the domain for g. So that means it needs to be in a and b. So that's what that intersection symbol, it means and. So again, I can make a new function f minus g by taking all the inputs of f and subtracting all the inputs of g. I can also make a new function fg, which is just you take all the outputs of f and all the outputs of g and you multiply them together. But again, in this case, we need stuff from this domain and we need stuff from this domain. And so since we say and, we do an intersection. And lastly, we can take f and divide it by g, which means you take and plug into f, take and plug into g, and then you divide what you have. Again, the domain is it has to work in a and b, but you don't want g of x to be 0 because you don't want to divide by 0. So hopefully all this makes sense, and the domain stuff will make sense the more we practice it. But again, you can make a new function f plus g. That's just take an output of f, output of g, and add it. You can make a new function if you have f and g. You can make a new function f minus g. Let's just take all the f stuff, all the g stuff, subtract it. And then fg would just be take all the f outputs, all the g outputs, and multiply them. And then lastly, you can do division by simply taking the outputs and dividing them. Okay, cool. So let's now find a whole bunch of new functions. Let's imagine I have this function f right here, and I have this function g, and I want to combine them to make new functions. Well, first, I can make f plus g. That would just be you take all of the old f's plus all of the old g's. So my old f's are this, and my old g's are this. So that would be our new function, right? So what do we worry about with respect to domain? Well, for this thing, x cannot be 2 for this piece. And for this piece, x has got to be greater than or equal to 0. So anything that I plug into this function, which is made up of two pieces, the inputs have to make sense in this piece and in this piece. So in other words, your x's have to be cannot be equal to 2, so it can be anything but 2, so there's a hole there. And then the other one says that you can be 0 or anything larger than 0, but you're not allowed to be stuff over here. So what you want is you want to be in this and this at the same time. So where's the intersection of those two? Well, it looks like if you live over here, then you live in both at the same time. So in other words, it seems like the domain of this thing, where it works here and here, is going to be from 2 out to infinity. Let's do f minus g. So f minus g is f of x minus g of x. So that means you're going to take your f of x function minus your g of x function. Your domain's going to be the same thing, right? Because in this piece, it can't be 2, and this piece has to be greater than or equal to 0. So again, the domain is going to be 2 to infinity. You can do f times g of x. It's just going to be f of x times g of x. So that means it's going to be 1 over x minus 2 times the square root of x. In other words, the square root of x over x minus 2. And again, that the domain, again, is going to be 2 to infinity. It's going to live in here and in here. And then the last one, let me add a page after. Then the last one, I could do f divided by g of x. That's f of x divided by g of x. So I take f of x, which is this, divided by g of x, which is that. But I know that that's the same as that over 1, right? Over 1. So when you take a fraction and divide it by another fraction, you simply multiply by the reciprocal. So we get 1 over the square root of x times x minus 2, right? And so in this case, the domain is still what we had before. You just have to watch out that the denominator can never be 0. And it seems like x equals 0 and x equals 2 are the only places we have to worry about, but neither of those are in this domain. So it doesn't add any further restriction. So there's all of our functions. Now it wants to know what happens if you have f plus g of x and you plug in 4. So let's plug in 4. Well, we just set up here that f plus g of x is 1 minus stuff minus 2 plus the square root of stuff. I just plug in 4 everywhere for x. So you get 1 over 2 plus 2. So that's 1/2 plus, 4/2? So you get 5/2. And I'll do one more. So there's that. Let's do f times g of 4. And I'll leave the others for you to try. F times g of 4, again, it simply means you take your function fg, which we had right here, and that function is the square root of stuff divided by stuff minus 2. You plug in 4 here and here. You end up getting 2 over 2, which is 1. So fg, that new function, when you plug in 4, you just get out 1. All right. Let's keep on going. Okay, so using graphical addition. So if we use graphical addition, it just simply means that if you have these two functions, so here is g, it gives you these outputs. Here's f, it gives you these outputs. And what I want to know is for any point, for example, this point right here, what do I get out of f plus g? Well, what it's going to do is it's going to take, one way to think of it is it takes this output and it adds this height to it. So I take that height and I add it up here. That's where your new point, that's going to be a point on f plus g of x. Because all you do is take the old g's and add f's to it, or either way you think about it. So that means here we're not going to add anything. Here at this point, we're going to add about that much. So it appears to be about that much. So it looks like we're going to go up about like that, something like that, right? Or how high did I say it was? I said it was that high. So maybe it goes something like this. That's going to be the most that I ever add from F. And then it's going to go down, and it looks like this is going to be a valley right here, where I just add a little bit. So I just add a little bit right here at that same X value. It looks like it's about that much, actually. So it needs to be the exact same amount. So it looks like it's going to come down like this. And then it's going to go up to another peak right about here of that much. So I need to add that much right here. There's going to be another peak right there. That should be the same amount. It's going to go up to that peak right there and then come back down. So it looks something like that. So you're just adding the heights together. Cool. All right. So now we've made new functions by adding, subtracting, multiplying, and dividing.